But before we have the pleasure of listening to the project presentations, I would like to welcome, first of all, the Global Biomimicry Network who joined us today, and especially representatives from Germany, from Italy, from the Netherlands, from the Austrian network, and also from other global networks, especially from the US. Before we listen to the students who are shown here already, I would like to also especially welcome the president of Biomimicry Germany, Arndt Pechstein. He is the project lead or a program lead and one of the major content creators and educators we have here. So I hope that Arndt is already with us.
I am, yes.
Hello, Arndt.
Hi, Fabian, and hello, everyone. A great pleasure to have you on this call tonight, or whatever time it is for you, depending on where you sign in from. Really great to have you all together here.
Yeah. Thank you for joining us. And so we heard the introduction and the background why it is so important to change, and we you perfectly outlined already the pillars that can lead this change, and one of the central aspects is biomimicry. And we at Biomimicry Academy want to take this nature inspiration as a tool of facilitate this highly needed change that we want to see in the world. I'm very happy that we had such dedicated and energetic students with us for the first cohort, and maybe you can give your impressions, Arndt, of how you see the last 9 months with these students.
Yes, absolutely. So maybe first to connect what we have been doing through the last 9 basically months and even before building up all these networks is something that so much gained relevance in the past weeks and months. If you look at the current situation, what is happening right now, this insane global lockdown, is actually not a result of a virus, but a result of a flawed system. And that is something that we have been working on to basically create an alternative for a long time. And that is why biomimicry and bio-inspired innovation at large is something that has a huge potential and will gain a huge momentum just now. Because what we're talking about right now in this crisis is really about how to adapt, how to create resilient strategies, how to be more sustainable. And going back to what we've just heard in the short input you have all seen, is that we need a narrative, we need a vision. And we all experience firsthand, and that is unique in almost like the history of humankind, we all globally and collectively experience a possible vision of traveling less, of being more at home, spending more time with people, reflecting on what is really necessary and having a sufficient and not an efficiency-driven life only. So this is something that really basically creates an even bigger need for these bio-inspired approaches, and that's what we've been doing also in this curriculum over the past month. And what we've been observing was a cohort of extremely enthusiastic students who have been diving into 2 challenges that we will see and hear about in a few moments. And they were really coming from various fields, from different countries, different backgrounds, and immersing into 2 totally different challenges. So one social challenge and more concerning society, one more technical challenge, totally different aspects, and yet using the same methodology and really diving into first what are the needs, what are pain points, what are requirements, defining the problem, then looking into biology for solutions, where we had amazing inspirational exchanges, where we had experts and disruptors as part of the process to basically look into what are those principles and strategies nature applies and how can they be abstracted, until they eventually came up with solutions. And that is so exciting because these things are actually projects that are not just made for the cohort and for the program, but these are real world problems and real world challenges that will continue to be worked on in the future.
That is exactly what is so important, and where we put so much emphasis in our program and beyond, and all the work that we do with the Biomimicry Network, is to bring the ideas, the prototypes, and the concepts we develop with biomimicry directly into application, to not just keep it in the theoretical realm or also in the ideal realm, but also to test it against the circumstances of the market and of the of society and of the world around us, because this is where it needs to have an impact. So yeah, thank you very much, Arndt, for this reflection on the last month, and you stay with us for some more minutes here in this webinar. And I'd like to invite you especially to ask questions to the participants, and yeah, address the challenges that they took on with their projects. And talking about this, I'd like to also welcome the challenge owners, which are Alessandro Villa and Diane Derby. And I'd also like to invite you especially to address questions.
So, hello everybody, and welcome to the presentation of our business challenge. We are Giulia, Alessandro, and Natasha, and in the Biomimicry Academy, better known as the Mangrove team. As we know, water is essential for agricultural production and food security. It is the lifeblood of ecosystems, including forests, lakes, and wetlands, on which our present and future food and nutritional security depends. Yet, our freshwater resources are decreasing at an alarming rate. Evidence suggests that 2/3 of the world population could be living in water-stressed country by 2025 if current consumption patterns continue. Agriculture is both a major cause and casualty of water scarcity. Farming accounts for almost 70% of all water withdrawals and up to 95% in some developing countries. We will have to use our natural resources more wisely. If we consider that about 70% of Earth's surface is covered in water, only 3% of all the water on Earth is fresh water. Of that small amount of fresh water, almost 2% is locked up in glaciers and ice at the North and South Poles, and less than 1% of fresh water is mostly groundwater. That means that the rest 97% of the Earth's water is held by oceans in the form of saline water. So why don't we use it? Planet, for example, is facing this challenge with the development of a desalination device, the Mangrove still. So let me spend just a few words about Planet. Planet is a startup specialized in bio-inspired design for sustainable innovation. It has been founded by Alessandro Villa and Alessandro Bianciardi in 2013. And although different expertise and professional background, both of them are into biology, complex biology systems, and bio-inspired technology. They both took part in a specific educational program at the Biomimicry Institute in San Francisco. And moreover, Planet is the owner of the business challenge we're presenting today. The Mangrove Still, it is a passive, low-cost, modular, bio-inspired solar distiller, able to produce fresh water from seawater or highly concentrated salt water, and it is based on the two elementary physical principles of evaporation and condensation. Planet is developing the Mangrove Still in order to help communities living in coastal degraded islands to irrigate and prompting reforestation projects using not conventional water resources, and therefore to contribute to the fight against water scarcity and the desertification intensified by the climate changes. Planet, in the context of our Biomimicry Academy, requests us to redesign the Mangrove Still desalination unit to allow modular production and reliable assembly. Briefly, I'm going just to present the team who took part in this challenge. So we have Natasha. She's an architect working in Germany. She focuses on sustainable building solutions as well as digitalization in the construction industry. Alessandro, he's a design engineer at Planet, and he focuses on bio-inspired design for environmental and industrial solution. And Julia, which is me, I'm an environmental engineer with more than 5 years of experience in aquatic biology, and I'm also part of the R&D team for bio-inspired solution at Planet. As we can see, we all come from different backgrounds, but we all share the passion for natural systems and bio-inspired technology. In the next slide, we would like to show the process we have learned and used to get through the challenge. It is inspired to the double diamond approach, which is probably the most popular design process visualization. Beside the description of the different phases of the process, the main feature of the double diamond is its emphasis on the divergent and convergent thinking. In the next slide, following the process you just described, we needed first of all to get a better understanding of the challenge. For this reason, we used a semantic analysis to expand the meaning of it. In the picture, you can see the deconstruction of the semantic of the challenge sentence. Moreover, we moved to analyze the mangrove steel technology in order to have a better understanding of the product itself, the process, the components, and the materials. After that, we were able to define some design constraints we needed to consider for our challenge, and here you can see a list of them. So for instance, the desalination unit has to be redesigned with a modular architecture, and it has to be waterproof, and so on. Afterwards, that was important also to define the involved stakeholders. In the process, we identified different internal and external players, as you can see in our map. But after providing enough information about each of them, we consider the fablets, the stakeholder with the highest impact of the assigned challenge, especially in terms of manufacturing process and material in this perspective of a decentralized production. For their implicit structure, Fab Labs bring with them a series of constraints here listed, mainly related to available technologies, processable materials, size part, and so on. At the end, we also defined the definition of the value proposition help us to better understand the challenge we were facing. With our product, we reduced the dependence of local farmers on conventional water resources. We reduced the water cost thanks to the decentralized passive desalination system based on the use of seawater and solar irradiation. We provide a scalable system according to the local needs, and we complete the agroforestry mission, prompting its practice using unconventional water resources. Eventually, the value proposition design, together with the design constraints, were used to identify the function used for the biological research later described. I pass the words to my colleague Alessandro.
Yes, here I am. Thank you, Judy. So sorry for the, okay, so here is where basically the human-centered design steps ends. And I mean, even if you need to consider the whole process as an iterative process, of course, here is where we jumped into the biological world, into the biomimicry approach. So first of all, we reframed the challenge, including two keywords, actually two functions that to achieve with the desalination unit. And here you can see is modular and foldable. So what we want to achieve unit and or foldable. So with these two functions, then entered to the discovering phase. That's really the biological work. And we started to wonder, how does nature like create foldable structure or modular elements, or still how nature arrange or make foldable structure and modular elements? And thanks to a series of tools like Ask Nature or reading scientific papers, we're able to identify a list of things and study them, like studying their function, mechanism, and strategies. And thanks to this list, we were then able to identify our biological analogy. And this is basically the etiology of stomach membrane. This is the organisms, let's call it, that we focus. And exploring and studying the stomach membrane, we understood the strategies actually that allow the membrane to be folded. So to have like the configuration you can see in the picture, basically. And there are three strategies that can be summarized as the tight junction, the morphogenesis, and the sculptoid shape. And we went into detail trying to understand the behind these strategies. And we focused mainly on the strict, you can see like on the upper part of the slide. And so that's allowed us to understand better the mechanism indeed. So basically, you have to imagine the stomach membrane as a patterned, flat, organic tissue, where the pattern itself is made of the cells, but it's thanks to that pattern that the stomach membrane is flexible and is able to gain 3D complex configurations. So we took this understanding and we extrapolated what we can call like design principles. And from understanding, basically we jumped from the biological world back to the technical side, back to the technical world again. And we defined our basically wanted to explore like a panel, a pattern panel that could like shape in 3D complex configuration, thanks indeed to that pattern geometries. So then we moved to the prototype step. We basically explored some materials, trying to understand their plasticity, trying to understand their elasticity. But basically what was really understanding in this, we were able to reach different 3D configuration according to the pattern itself that we were able to imprint on the panel. And another important aspect that led us to proceed on the path was whether like external references, like for example the wood skin, that is like a double plywood panel with elastomerical layer, but that thanks to the pattern they were able to to provide to this plywood like flexibility. And here is like a concept summary. I pass the word to Natasha.
Yeah.
Okay.
Thanks, Alessandro. So after this stage of the process, we had a better understanding of what modularity really meant. We wanted to summarize our findings for the next stage and to keep reminding ourselves which are our key goals. So basically, we wanted to remember that this is a single unit, a whole unit that should be or could be divided into subunits. An important factor was the ability to have different 3D configurations that can be adapted according to the site. And another aspect to explore was the use of one material. So building up from the first design phase, we decided to look at the Voronoi pattern. The Voronoi pattern was actually something that we already discovered during one of our biological research processes, and we thought maybe a biological pattern could give us more information on how to further develop a design. Voronoi can be found in all aspects in nature, for example, in leaves, reptile skin, and the pattern can help solve geometric problems like packing, strategic placements, and patterns of growth. So in the next slide, you see just a quick understanding of Voronoi. Imagine a large field, and on this field, there are a number of fires that are set on it simultaneously, and they all spread in all directions at the same rate. So the Voronoi diagram describes both the location of which these fires are set, meaning the Voronoi site point, and the boundaries at which adjacent fires meet, meaning the Voronoi region. So basically, Voronoi has an important property property of understanding spatial relationships, adjacencies, and neighborhoods. Throughout our research, we came across a study done by MIT that combines origami folding techniques with the Voronoi pattern. This technique actually uses a different strategy for folding a material to make a polyhedron, which is a 3D shape with flat polygonal faces. The original origami folding method, seen on your left, is called the strip method, and this is a combination of folding including weaving and dividing the material into strips. This method is, however, inefficient because it's unable to create a scaled version of a polyhedron, and it wastes a lot of material. The new algorithm, seen on your right, has no holes, no gaps, no slits in its internal boundary. This makes it watertight. In the next slide, you see how this algorithm is defined. It's pretty complex. Basically, you map the facet of the desired polyhedron onto a flat surface. This facet will be touching each other once the folding is complete, but in reality, they can be quite far from each other on the flat surface. The trick is to fold away the extra material in order to bring together the faces of the polyhedron together. And this can be seen in the second and third method called the tuck proxy waffle method. The folding away of the extra material process can be very complex and involves hundreds of individual creases in order to calculate the most efficient crease pattern and reduce it to a minimum. This is where the Voronoi diagram comes to play. The boundaries created by the Voronoi diagram is what defines the creases of the algorithm. In the next slide, you see a video that shows the algorithm being used. So here you see a 3D object, and you can unroll the object and see the different pieces, as well as the crease patterns. Underneath, you see the waffle foldings. And once a facet is selected, you see that it is not exactly lying adjacent to the next facet. In the next video, you see that this is a basic Voronoi diagram with 4 points, and the red lines that constitute the Voronoi arcs then cause the folding of the 3D object. In the next slide, you see the program once again, how we can imagine using different geometrical solutions that we can imagine for the unit. So after our research, we found that this, by using these tools and this algorithm, there's really a reduced need to transport a physical product, as everything shall be, let's say, digitally produced or can be transferred to files, which then can be later produced decentralized in a fab lab. The methods also do not use molds. They can be rather created using CNC, laser, or 3D printing. And through using this algorithm, we can provide different configurations and shapes. As for further investigations, we would like to explore different polyhedron shapes for the unit, using the program to then identify an efficient folding pattern using the Voronoi. We would then use a CNC machine to test out these findings. We could consider shape memory in terms of materiality. We could consider shape memory alloys, as well as methods of 4D printing. And this is really to make sure that the unit is programmable, in the sense that it can adapt to a local condition, be it space or temperature. The unit can be more flexible and more attuned to be more dynamic. For example, with the shape memory alloy, it responds really well to thermal conditions and has a kinetic response, meaning that it extends or compresses according to the heat. In the end, we imagine similar configurations as seen here. Using this algorithm and using the knowledge that we have acquired right now, we see vast opportunities that we could use, leaving a lot of source of inspiration of how we imagine the unit to be produced in the next stage. Thank you.
Well, thank you for this great presentation on a very exciting project, and that addresses, again, pretty much what we've been talking about before. We're saying we want to not only use bio-inspiration for the sake of it, but to bring it into application. So thank you very much. So the floor is open for questions. Maybe I'll start right away. So you have very well outlined your concept from taking the idea from low tech with maybe the wood skin like setting towards a high tech by using the Voronoi algorithm. Now, a question I got online is, do you use the mangrove still already, or what are contemporary methods for desalination?
Yeah, thank you, Fabian, and thank you, whoever. Yeah, actually, the mangrove still is a planet project. I don't know if Alessandro Villa is here with us, but he's the co-founder of.
I'm here.
Okay.
I'm here.
Okay.
Hello, everybody.
Alessandro.
Okay.
Hello. Go ahead, Ale. You can
Okay.
You can explain. Thanks.
So basically, yeah, the mangrove steel is currently used. Actually, it has already been tested a couple of times, actually, with 2 pilot tests, once in Cyprus and one in the north part of Italy, and it's going to be tested again with let's say a 3rd pilot in Greece. Like it was supposed to be this summer actually, but now it's going to be postponed because I mean, you know the reason. And that's actually a really basic desalination process. It's based on evaporation, condensation, triggered by the sun irradiation. So it can be really considered like a passive desalination strategy. Currently, I mean, it's worldwide. It's not, of course, the most common technology because basically the efficiency is not that high. Normally, like countries use reverse osmosis processes that is based on membrane filtration, let's say. But the point is that these like huge industrial plants are really energy demanding and require a lot of initial investments, and are not cannot be considered as decentralized technologies. While the concept of the mangrove steel is indeed to be decentralized, low tech, let's say, technology, and mainly to be modular, which means that you can enlarge it and scale it according to the local needs. So based on the water demand of the context. I make a big overview, so I hope I replied to the answer.
Yeah, no, that was great, absolutely. Alessandro Villa, welcome from my side as well. As a challenge owner, do you have a question to the team?
Okay. Hello again. So first of all, my compliment, because honestly, this is the first time I saw the outcome of your work, and I'm quite proud of it. And yeah, there is maybe I have not right now a question, but honestly, hearing the presentation, I'm quite confident we could move forward with in this direction. Basically, one of the points will be to apply this design system to the specific material, or utilizing a material with the proper mechanical properties. And we now choose the thermoforming process to produce the desalination units, because we were able to find, how to say, a good compromise between the price and mechanical properties, because this material has to last at least 130 degrees. And so I'm very curious. I'm very curious to work together to find out a material able to last the needed mechanical properties, but also workable with CNC machining according to the algorithm. Yes. Yeah, this is my first comment. Yes. Yes.
Yeah, thank you for that. And so yeah, what you see is from every result, there will be new challenges coming up. Now, one question that was asked online is, what was your biggest challenge during the project? And maybe connected with this, another question, what was the biggest paradigm shift you realized while you were working on the project? So that goes out to the project team.
Okay, yeah, I guess so. Can you tell me again the first question? I missed it.
What was the biggest challenge you faced in the project?
The biggest challenge was really two biggest challenge, I would say. The first was to semantic analysis. So it was really to understand some kind of keywords that were crucial and critical for then develop the project. So really to understand what, like, for example, modularity, or what was the meaning of modularity for the challenge owner. So what was the wish at the end? That's what was the first problem, let's say. And second one was really to go deep in the biological research, because the vocabulary, generally speaking, is really different from from at least the one I was used to. So like the collaboration with biologists and some experts were crucial to districate the complexity of the biological research.
Yeah, thank you very much. And you pointed it out very nicely. One of the most important phases is actually the first one in the process. Is the understanding phase, because it sets the ground for everything that comes after. And moreover, you always go back, right? Whenever you have an answer, there will be new questions arising that you will need to reconsider, rephrase, and then research. I would like to use the last 5 minutes to open up the Biomimicry Academy online platform. As we've heard in the introduction, the responsible innovation education in the Academy comprises of 4 pillars and starts with human-centered design, with the design thinking process, and more generally speaking, the double diamond. The center and core of the whole education is based on the biomimicry and nature-inspired innovation process and framework. And it leads over towards systems thinking, and the most practical approach to it is the circular economy, which combines biomimicry with business modeling on the other side, on the other end. Now, in the business section, in the last part, we integrate all these learnings and the concepts into actual application on the market or in social innovation, with the frameworks of exponential organizations, classical business modeling that leads towards communication and community integration. I'd like to mention that we operate in a global network of biomimicry and nature-inspired and research institutions, most prominently the European Biomimicry Alliance, the Biomimicry Institute in the US, the Natural History Museum here in Berlin, and of course the center of all our activities, the brain and people power of Biomimicry Germany. Now, the Biomimicry Practitioner Online Essentials is the training program, that part of the Biomimicry Practitioner training that is completely online and self-paced. It comprises of 3 modules. The first module consisting of 3 chapters and having a learning content of about 30 hours total, which you can go through in a self-paced manner. And we open up this module today. The second module has, again, 3 chapters with the same setup, and leads from human-centered design and biomimicry over to systems thinking, to circular economy, and then apply biomimicry to its challenge. We open up this module 1 month later, on May 4, 2020. And finally, the third module consists of 2 chapters. The first one being business modeling, and the second one having to one aspect or addressing aspects of communication and go-to-market processes and skills, but also community integration. And we open this again 1 month later at 1st of June. It's not only an education program, and you are not left alone. What Biomimicry Academy as a platform, having add-on courses, but also a mentorship program. So join our weekly office hours when you participate in the Academy, or when you have questions that you would like to have answered before you start the Academy. Now, the online essentials are the entry points into the Biomimicry Practitioner certification program, and the second part of this program is the project training. It will be online as well, but having on-site aspects that are optional and add certain benefits of doing research on-site and immerse into nature and to connect to the community in Berlin. Now, this second part of the program is meant really for entrepreneurs and social innovators in general, and it goes from scoping your own goal and research your users in the first place to create sustainable solutions using the human-centered design and the biomimicry process and everything you've learned in the online essentials, to finally create your business and take your ideas either towards pitching them in a company or bringing it to the market and communicate it and come out with a marketable, minimal viable product. Now, 2 things I'd like to mention on top of this is that we will set up a Biomimicry Academy Global Philanthropy program coming up in April 2020. And we want to not only make the Biomimicry applied program available in Europe or in the Western countries by charging a certain amount that is reasonable in these areas, but we also want to make the program available to countries, especially of the global south. And for this, we couple the pay for the program to the GDP of the country. So this is coming up in April, and we'll update you on our channels, on our social media channels, and on Biomimicry Academy and the newsletter. Now, secondly, I'd like to address that attached to the Biomimicry Practitioner education and the Academy is our co-creation platform, Cobiome, where we use a global network and a digital co-creation platform to solve challenges from social innovation, so non-profit challenges, but also especially from businesses who want to become sustainable and innovate responsibly. Graduates from the Biomimicry Academy automatically enter into this pool of experts who can co-create on the platform. And if you want to know more, follow Cobiome on the social media channels. Now, I'd like to mention in this respect that we follow the principles of the Radical Collaboration Manifesto of the Responsible Innovation Network. And if you want to know more about this, so the foundations and the statutes of cooperation instead of competition in business and in all innovation that we do, then check out this website that is linked up here or you can use the QR code. So finally, there's nothing more to say, but please visit www.biomimicryacademy.com, and if you are interested in attending one of our courses, make use of your attendance to this webinar by using the voucher hashtag webinar 202064, secure your 20% discount. So with this, I'd like to thank you again for your participation. I'm looking forward to seeing you again during our training program.